In this lecture, we take an example of Taylor's theorem. The example is applying Taylor's theorem to express 61 minus 84x plus 46x squared minus 11x cubed plus x to the power 4 in powers of x minus 2. Let fx be a function of x differentiable n times. Then Taylor's series of f of x is given by f of x, which is equal to f of x minus a plus a, which is equal to f of a plus x minus a f dash of a plus x minus a whole square upon factorial 2 f double dash of a, and so on. Let us give it equation number 1. Here, f of x equal to 61 minus 84x plus 46x square minus 11x cubed plus x to the power 4. Therefore, x minus a, this x minus a is equal to x minus 2, because we have to express in powers of x minus 2, which gives us a is equal to 2. From equation number 2, we have f of x equal to 61 minus 84x plus 46x square minus 11x cubed plus x to the power 4. Now put x is equal to 2. We have the value of f of 2, which is 61 minus 84 into 2 plus 46 into 2 square minus 11 into 2 cube plus 2 to the power 4. If we simplify it, 61 minus 168, 46 into 4, which is equal to 184, 11 into 8, which is 88, plus 2 to the power 4 is 16. And if we simplify it, we are getting 5. Now, we have to differentiate f of x with respect to x. So, its derivative of 61 is 0. Derivative of minus 84 is 84x is minus 84. 46x square is 92x. Minus 11x cube is 33x square. And derivative of x to the power 4 is 4x cube. If you put x equal to 2, we are able to calculate the value of f dash of 2, which comes minus 84, 92 into 2, minus 33 into 2 square, plus 4 into 2 cube. If we again simplify it, minus 84, 92 into 2 is 184, minus 33 into 4 is 132, and 4 into 8 is 32, which is equal to 0. Again, differentiating this f dash of x with respect to x, its derivative is 0. Derivative of 92x is 92. Derivative of 33x square is 66x. And derivative of 4x cube is 12x square. If we put again the value of x is 2, we have 92, 66 into 2 plus 12 into 2 square. If we again simplify it, 92 into 132 plus 12 into 4 is 48, which is equal to 8. Again, differentiating this f double dash with respect to x, derivative of 92 is 0, minus derivative of minus 66x is 66. Derivative of 12x square is equal to 24x. If you put x equal to 2 over here, f triple dash of 2 is equal to minus 60x plus 24 into 2, and which is minus 66 plus 48, which is minus 18. f4 dash of x is equal to 24, because derivative of minus 66 is 0 and 24 is 24. So f4 dash of 2 is equal to 24. Now, if we put all these values, f of 2, f double days of 2, f days of 2, f double days of 2, f triple days of 2, f4 days of 2 in the equation number 1, then f of x equal to f of a plus x minus a, f days of a plus x minus a whole square upon 2 factorial, f double days of a, and so on. Then f of x is f of a means f of 2, a is equal to 2 over here. X minus a means x minus 2, f days of 2, x minus 2 whole square upon 2 factorial, f double days of 2, x minus 2 whole cube upon 3 factorial, f triple days of 2, x minus 2 whole to the power 4 upon 4 factorial, f 4 days of 2. And substituting all this value, f of x is given as a question 61 minus 84x plus 46x square minus 11x cube plus x to the power 4. And f of 2 is equal to 5, x minus 2, f double days of 2 is f days of 2 is 0, plus x minus 2 whole square upon 2, f double days is equal to 8, and x minus 2 whole cube upon 6, 3 factorial is 6, f triple days of 2 is minus 18, x minus 2 whole to the power 4 upon 24, f 4 days of 2 is equal to 24. Now if we simplify it, this will become 0, 2 1s are 2, 2 2s are 2 4s are 8, 6 1s are 6 3s are 18, and 24 1s are 24 1s are. Now if we simplify it, 5, this is 4 times of x minus 2 whole square minus 3 times of x minus 2 whole cube plus x minus 2 whole to the power 4. We have expressed 61 minus 84x plus 46x square minus 11x cube plus x to the power 4 in ascending power of x minus 2. 5 plus 4x minus 2 whole square minus 3 times of x minus 2 whole cube plus x minus 2 whole to the power 4. Therefore, this is equal to this. This is a desired Taylor series expansion of the given expression in powers of x minus 2. Thank you.